Okay, problem number 7. On the moon, the acceleration due to gravity is negative 1.6 meters per second squared. If a stone is dropped from a cliff and hits the surface of the moon, 10 seconds later, how far did the stone fall? And what was the velocity of the stone at the time of impact? So we are starting with an acceleration equation, a of t. It equals just that constant term, negative 1.6. And so if we integrate acceleration, we'll get velocity, v of t. And so we'll get negative 1.6 t, and then we would have a plus c, but since the stone is being dropped, its initial velocity is 0, and when you integrate acceleration to get your velocity function, that constant term is your initial velocity. So since this is 0, since we're dropping it, we stop our equation right there. And we will integrate again to get our height function, h of t, will equal t squared, and then we'll take 1.6 and divide it by 2 to get negative 0.8 t squared, and then we need to have plus h naught, our initial height. We don't know our initial height. That's what we want to find. If we find that, we'll know how far the stone fell. But we do know that after 10 seconds, the height of the object is 0 because it's on the surface of the moon at that point, which has a height of 0. So we can say 0 equals negative 0.8. T is 10 squared plus h naught. And so let's simplify that. 0 equals 10 squared is 100. Negative 0.8 times 100 is saying, hey, let's move that decimal 2 spots, so we will get 80. So negative 80 plus h naught, and so add 80 to both sides to get 80 equals h naught. So we know that the stone fell 80 meters because, we just did some math. Okay, well, what was the velocity of the stone at the time of impact? Well, that's v of t. The time of impact was 10 seconds. So v of 10 equals negative 1.6 times 10 seconds, which equals negative 16, I think is how math works. So negative 16 meters per second was the velocity at the time of impact. And we're done.